Hello students, welcome to this video tutorial on strategies to find linear relations note, part 3. Okay, so in this video we're going to look at section C called the multi-step linear relations. So multi-step means we've got a couple of operations working. So I've got a good hint up here, and the hint is we usually have multiplication and then addition, adding a number, or multiplication and subtracting a number. These are the most common. Now, these are not the only type of multi-step problems, but these are the most common. Multiplication and then adding a number, or multiplication and subtracting a number. So let's try to keep these in mind as we tackle example 4 and 5. Okay, so again, highlighted in yellow, what do we do to n to get a? So we've got our column headings of n and a again. So we've got a value of 0, and then it goes up to 1. We've got a value of 1 that ends up as 3. We've got a value of 2 that ends up as 5. So the best way to do this is do it systematically. Okay? So if we know it's multi-step, and the majority of the questions are going to start with multiplication, then start with multiplying by 2. So if we multiply 0 by 2, we don't get 1, do we? Okay? So up here, it's kind of nice to write down the strategies that you're using. So if we multiply by 2, that doesn't work. But what if we multiply by 2 and then add 1? Okay? So does that work? If we multiply n times 2, we get 0. And then if we add 1, we get 1. Hey, that works. So let's see if that works over here. We multiply n, which is 1 times 2, we get 2. And if we add it to 1, we get 3. So that works. If we multiply 2 times 2, we get 4 plus 1 equals 5. So right away, the very first one I tried, it works. So this is a good one to try. So if this one didn't work, then a good idea is to try it 2 times, multiply by 2, and then plus 2. Multiply by 2, and then plus 3. So that way we're checking these off systematically. Now, if you get all the way to 2 times something plus 15, or 2 times something plus 16, you're probably not in the right area. So then you can try 3 times. So maybe we can talk about that for the next example. Okay? All right, so what did we do to n to get a? Well, we multiplied by 2, then we added 1, didn't we? Okay? So I've already checked it, but it's important that we kind of keep the same strategy going. So multiply by 2, then add 1. Let's check them. 0 times 2 is 0 plus 1 is 1. 1 times 2 is 2 plus 1 equals 3. 2 times 2 is 4 plus 1 equals 5. So we know that those three work for this strategy. Okay? All right. So now let's describe the rule in words. Well, we kind of almost already did up here. So the only thing we have to add really is we're going to start with a number. So a number multiplied by 2 then added to 1. Or then you could have put then increased by 1. Okay? A number multiplied by 2 then added to 1. Okay, so let's go in and finish the value table. So now that you know the rule, I'm going to give you a head start, and I want you to complete this table. Okay. Now it is not necessary for you to write these arrows. I'm just kind of doing that as a stall technique so that it gives you a little bit more time to work these out. Now I'm hoping you can do most of these just with mental math. Okay, so hopefully you got these three A values, 7, 11, and 21. And hopefully I didn't make a mistake this time. Okay, so let's go to the last section here. Write the linear relation as an algebraic expression. Okay, so what was the first thing we did? We multiplied a number by 2. So we know how to write that. A number multiplied by 2 is 2n. Remember, it's not n times 2. It's not n2, it's 2n. And then what did we do to it? We added 1 to it. So this is the algebraic expression. We've seen this algebraic expression before in our previous activities. Okay? So that's example 4. So you think you're ready to try example 5? All right, strategy. What do we do to n to get a? So we have a value of 1, and then we end up with 1. So again, this is always very tricky. So how about this? We have a value of 3, and we have 11. And then we have a value of 7 that ends up as 31. Okay, so you know that this is going to be a multi-step. So you're not just thinking about multiplication. You're thinking about multiplication and addition, and multiplication and subtraction. Now I'm going to give you a big hint here. We've already done the multiplication and addition. So why don't we look for something that is multiplication and subtraction? Okay? So when you're going through your strategies, don't just randomly pick an algebraic expression or a strategy. Start with a system. So the best one to start with is 2n, 2 times a number, subtract 1. And then if that doesn't work, try 2n, subtract 2. And then if that doesn't work, try 2n, subtract 3. Now after a while, you'll realize that, you know what? It's not really working. The 2n, this number that we're multiplying by is not big enough. So then you have to go up to 3n minus 1. And then 3n minus 2. So it's very easy to check right away. So if I use 3n minus 1, 3 times 1 is 1. 3 times 1 is 3. Subtract 1 is 2. So already I know this doesn't work. So let's try it again. How about 3n minus 2? Okay, so 3 times n is 3. Minus 2 is 1. So you might be thinking, oh, okay, well this one might work. So let's check it for the next one. 3 times 3 is 9. Subtract 2 is not 11. So that doesn't work. Okay, so you see how you have to go in a systematic way, or else you're just randomly guessing. And that's not what you want to do. When you're trying to find a pattern, you can't just choose things off the top of your head. You have to eliminate things and go in a logical manner. Okay? So hopefully all this time, these hints that I'm giving you, you're working it out. Now, let me give you a hint while you're working on this, is that I'm probably not going to give you something ridiculous like, let me just write this down here, like something like 56n subtract 84. Okay, this is not something that I would give you. This is a ridiculous question here. Okay, that would take you so long to figure out. Okay, so again, when you're up into this amount of numbers, you're on the right track. You're not on the right track, I should say, because I'm never going to give you a question like that. Perseverance is very important when you're trying to find a pattern. You can't get frustrated. You have to keep searching. So how about something like this? Maybe some of you have it already. Some of you are getting close. So what if we start with multiplying a number by 5? And minus 4. Okay? So if we were to describe that in rules, as a rule, sorry, so we can go a number. Actually, what I should do is I should check it first. So 1 times 5 is 5, minus 4 is 1. 3 times 5 is 15, minus 4 is 11. So two of these numbers work. 7 times 5 is 35, minus 4 is 31. Okay, so I know that this is the rule. Okay, I can finish writing it now. A number multiplied by 5, then subtract 4. Okay, you could put then minus 4, you could put then decrease by 4, it doesn't matter. You could have written the difference between 5 times a number and 4, that would have been fine. Okay, so now I want you to complete the value table. Here a calculator might help. So did you get the same values that I did? Okay. All right, so now let's translate this into an algebraic expression. So a number multiplied by 5 is 5n, and then if we subtract 4, this is our algebraic expression. Okay? So obviously, multi-step problems are a little more challenging than the single-step problems. But again, if you use a pattern, if you use a logical approach, then you should be able to find the pattern. Okay, so this concludes part 3 of this supernote, this video on strategies to find linear relations. Thanks for watching. Bye.